Welcome everyone, and thanks for joining. I'm joined here today with Xavier Laxa from Catapult Software. He's the global sales channel manager for them. Just a little bit about Catapult Software as well. Catapult is a software developer located in New Zealand, and we've been working together with Catapult for over 17 years, working together really to deliver a lot of different power and energy applications. They are a big part of our ecosystem, and also even a reseller for our software. If we start looking at just a big thing that's happening in the industry today, and really there's a lot of change in the landscape, including things like renewables. Obviously, a lot of people pushing towards renewable energy sources, lots of energy management. But a lot of this is burdened by just some of the things that are in place today. As an example, only 4% of various operators in the world that are working in the power industry are leveraging their data effectively. A big part of the challenge is a lot of the information is unstructured and fragmented, and really operators need tools which is going to let them really leverage the power of that data, so essentially to turn it from data to information they can leverage. There's also a lot of change in the energy landscape around suppliers, different suppliers, new energy producers, again, talking about some of the renewables and things like that are entering the industry. There's a big need for suppliers really to communicate with each other across those different producers, more and more than ever. And things like that are going to require things like tools that are web accessible, dashboards are going to become even more important in those situations, and really being able to have that data and visibility so that you can handle things like extreme weather conditions or other catastrophic industry supply failures, as an example. Another big burden with the industry today is that there is an aging infrastructure. While we are there's a lot of new energy producers coming up with renewables, like we talked about. There's still a lot of the grid is still operating beyond its lifetime. So a lot of systems are in desperate need of upgrades, especially to handle that increasing demand on the power grid that we have today. There's also a lot more security concerns than ever before. I think we've all heard the news articles in various industries, including the power industries, where systems have been compromised. There's definitely increasing cyber threats in the industry. And really, being able to stay on top of those is one of the key things. There's several bad actors out there that are trying to penetrate various grid systems, as an example. And then, of course, again, coming back to a lot of the sustainability and renewables and things like that, there's going to be an increasing regulatory requirements around just a lot of these industries that are going to continue to come, as well as, of course, the pressure to meet a lot of our climate goals, and in some cases, government regulations that are driving those. All these are really going to drive the need for more standard reporting, and really, when it comes right down to it, being able to measure is really the key to achieving those goals. If you don't know where you're at today, it's hard to know if you're improving and able to meet some of the goals that are being set forward. So if we start looking at what the future of energy systems management is, it really comes down to gaining visibility and control of those systems. So, a big part of what we'll talk about today is around getting visibility and control. And, really to provide that, it's just important to consider some of those changes that we've already talked about today. So in many cases, you'll run into a lot of different software systems and hardware systems across, the multiple power generation sites, whether it's traditional or renewable. Being able to provide tools to really help modernize the workforce, make sure they have the real-time information they need to access their systems and do that control that they might need to do. Security, as mentioned, is a key. Also, the ability to be agile when interfacing with all those systems. As mentioned, more and more systems are coming online. More and more power producers are looking at trying to figure out how do they get a holistic view of their system. And, especially being able to do things like operate things remotely or, potentially in some cases doing control remotely. So visibility is really key to that. Getting to that stability and maturity of those platforms is really going to help with that. So continuing to stay up to date. It's, as mentioned previously, there's a lot of aging systems out there. I think now more than ever, the pressure if some operators are using some of those legacy systems really to move them forward. That pressure is continually increasing. And as we start collecting more and more data and information from these systems, as mentioned previously, there's still not a lot of usage of all that data that is being collected. You'll start to see analytics become a play. So if you aren't getting at that data today, really, if you want to start getting into that, new age of digital transformation and analytics, it's something to look at as well. The real goal around that is to ultimately help reduce your energy footprint, reduce costs, and ultimately, be a good global citizen as well with that. And then, of course, more and more the end customers are looking for information on where their power is coming from, what's your carbon footprint, all those things, especially if you're whether you're a producer of energy or a consumer of energy. Those things are going to start coming more and more into play. So in order to provide that information, you really do need a system that's going to let you integrate in and get all that data from those various energy systems that you might have. So now, we'll take just a quick look. As mentioned at the beginning, we do have our partners from Catapult on the line, and they're going to talk a little bit about iPower, which is one of those enabling technologies that's really going to help you get visibility into either your energy production or energy usage. And so what is iPower? Ultimately, as I mentioned, we're in the automation business. We do have HMI SCADA solutions that are used across various industries, including power, facility management, energy management, manufacturing, and much more. So those tools are great, powerful, general purpose SCADA systems. What iPower does really is provide a set of tools that complements the HMI SCADA solutions to really help accelerate the time it takes to build and ease the maintenance of your systems that you might have in place. So I'm not going to go through all of these, but ultimately it's really about providing the controls, the tools that are required to help build and maintain those applications quickly and easily. So, looking at some of the advantages, it does provide a secure and consistent control interface. There's some tools that are out of the box that are really going to help with, just making sure that the interface is consistent regardless of which system you're looking at, if you are looking at multiple systems or even across, different assets within your system. The idea is consistency is really helpful in terms of from a safety and security perspective. It also provides a lot of power-specific objects, and Xavier will go through some of these in a demo as well a little later. But the idea there is by having a lot of those pre-built objects and graphics for specific equipment, example, circuit breakers and things like that, you're not having to build those by yourself out of the box. So they're there and ready to use and provide that consistency across the application. There are also several tools that make the overall system easier to configure and work with, including things like navigation and some of the things that are really important, like control, being able to do safe control within the system. And really, it's about lowering that total cost of ownership by just having some of that standardization really helps with that as well. So it is consistent and easier to maintain. If we look at some of the things we talked about previously around just some of the things that are changing, whether it's obviously a lot more companies are concerned with sustainability, whether you're a consumer or producer. So things like energy management, for whether it's industrial manufacturing or whatever, even things like water systems or large energy users, being able to have visibility into those systems and get the data out of those systems is really the first step to how you can reduce your footprint as well. So if you start thinking about, it's a daunting task when somebody says, hey, you need to cut energy usage by 20% or something like that. The reality is if you're not measuring your usage and where it's coming from, it's going to be a really difficult task. So it's really key for some of those large power producers to be able to put systems in place to really measure the usage. Things like critical power delivery. If you start thinking about data centers, various facility management systems and things like that where backup power is required, you often need to make sure that you have visibility into the operation of that backup power system as well. Probably the most common use case, for a lot of these electrical applications are substations. So if we start looking at substations, really the key here is, being able to have a good, easy to use interface with those safe controls that we talked about is really critical to those applications. And then, if you are looking at more than one energy source, or one grid or microgrid, you might need to start looking at, having that central control room that can really tie a lot of that together. And you see a lot more of that, especially now with some of the renewable systems like wind and solar. You pretty much you don't want to be going out to those systems every day. You need to put together some sort of a central control room that is going to allow you to get visibility of the entire system so you can manage and optimize it centrally as well. So with that, I'm going to hand it over to Xavier, and he's going to give us some more detailed information on how iPower can really help you meet some of these new energy needs that we have in the industry.
Thank you, Jimmy, and hello everyone. Today I'm going to talk about some of the key features of iPower and how you can use it in your systems to provide a number of features that are all available out of the box. iPower is a suite of tools added to your iFIX or CIMPLICITY system that enhances several tasks such as deployment, navigation, events, alarms, image arrangement, and display options. iPower is designed to serve the unique operations, safety, and control requirements of electric utility and energy management operations. But as you will see in the demo, it's not limited to that market, as a lot of the features are readily applicable to just about any other industry. So there are a number of benefits to using iPower for various users of the system across the board. For system integrators and SCADA engineers, the deployment tools and readily available objects like menus and lists make system configuration a breeze, saving time and money on deployment. For operators or SCADA users, the alarm management features and secure control dialogues in iPower provide a wealth of tools that allow operators to securely and effectively manage the state of the SCADA system, and this improves overall user experience. And finally, for management, aside from the benefit of increased productivity, iPower provides a consistent and future-proofed investment, lowering the cost of ownership. So these are all the features available in iPower, some of which we will be discussing today. As you can see, iPower provides features for various stages of a system's development, from design and implementation all the way to maintenance and auditing. Tools like DB Architect help with the rapid implementation of databases, while the out-of-the-box menu, lists, and dynamos in iPower allow for easy configuration of displays without the need for additional coding. The The secure control dialogues and alarm management features in iPower help operators to maintain control of the system, while the event logs provide an easy way to keep tabs on system events and greatly assists with audits. We will be looking at these features in greater detail during the demo. So iPower is a product that's continually evolving with iFIX and Simplicity, taking advantage of new features with each system as they become available. Some of the versions that are about to be released include support for high-performance UI, multi-alarm operations, Python scripting for simplicity, and support for Configuration Hub, as well as a browser-based configuration interface for iPower in order to make maintenance that much easier. We've also added support for 61850 and improved the Edition 2 features that are available within iPower. There are also more features planned in the future, such as support for solar and wind farms, and improvements to the database engine within iPower. This roadmap is largely customer-driven, however, and we are more than happy to listen to any suggestions for features that would be most beneficial to current and future users. So with that out of the way, let's just jump into the iPower demo system now.
So this is the iPower demo system. It's available as part of the standard iPower installation package and provides a number of example systems to show what iPower is capable of. Here, for example, are a number of substation diagrams drawn in different styles. We also have an example water treatment system, a critical energy management system, and an example application of iPower for the oil and gas industry. This is actually the demo system for iFIX, but there is an equivalent demo system in Simplicity. What you'll notice with the two demo systems is that they have the same look and feel, right down to the control dialogues that are available. This makes it a great platform to standardize your systems, as no matter which you're using, the UI will be the same, cutting down on the need for repetitive training of users. For this webinar, we'll mostly be using the iFIX demo system, but we will cut into the Simplicity system for some features that are exclusive to that platform. So as you can see here, we've been using the menu above to navigate between the different pictures, and this is actually the iPower main navigation menu. It's an out-of-the-box and complete navigation system, which means there's no coding needed to gain the required functionality. By default, the menu includes standard functions like back, forward, home, and favorites, though it is completely user configurable. Users can navigate to any picture or configuration tool, such as Database Manager or Mission Control, as long as they have the correct access level, of course. So let's go to Configure mode and have a look at how to create and configure a menu. Creating a menu is easy. You just need to add it into an existing picture from the iPower toolbar, and then position and resize it as needed. Note that you can display the menu either horizontally or vertically, depending on your requirements. You can make changes to the menu by right-clicking on it and selecting the Menu Properties option from the pop-up menu. And from here, you can set a number of options. You can define several submenus, which you can then attach to a menu button, and then change the layout of the buttons on the menu. Finally, you can change generic properties, such as the default picture to display when the menu launches, or whether to display buttons as text only, image only, or both. Note also that iPower already provides some of the most common actions as pre-configured options, which can be attached to either submenus or buttons. However, if the action you need is not in the list, you can also create custom actions using VB scripts. Each action can also be tied to either the iFIX or Simplicity security system to make sure that only users with the proper credentials can access these actions. So here you can see one way that iPower makes it easier to implement projects. Navigation tends to be one of those parts that can be costly in terms of design and implementation. But because iPower's menu is available out of the box while being highly configurable, you can spend significantly less time on design and coding. Plus, you get the added bonus of a secure and consistent menu system, helping you to cut down on user training. So that's an overview of the menu navigation tool provided by iPower. Now let's have a look at another feature, which are the list controls. So the list control is an object that you can add to any existing iFIX or CIMPLICITY picture. It provides a summary of various tables of data presented as a list. The most common forms of the list are the alarm summary and the events list, but you can also use the list control to display disabled or shelved alarms and even a real-time data summary list. All lists have common features between them, such as the ability to create a filter or do advanced sorting on multiple fields. So for example, this data summary is a list of all the points in the SCADA database. As you can see, it can be very hard to look for a specific point, but I can use the quick sort feature to quickly reorder the list, or I can use the advanced sorting feature to sort on multiple fields on a priority basis in either normal or reverse sorting order. Even better, I can use the quick filter controls on the banner at the top to quickly drill down to a specific set of points. For example, if I just wanted to concentrate on the water treatment system, I can use the filters to quickly go to those database points without having to create a query command, making it easier to find points of interest. You can also make a selection of items in the list and either send them to a printer or export them to a CSV file, which can then be used in other reports. There are other special options available depending on the type of the list, which we will be showing later. Now let's go into configure mode to see how to create and configure a list control. So just like with the menu, adding a list to a picture is easy. To add a list, you just need to select the Insert List option from the iPower toolbar, and then resize and position within the picture as needed. As you can see here, I can resize it to either occupy the entire screen or just shrink it down to a small banner. Just like with the menu, you can also set the properties for the list by right-clicking on it and then selecting the List Properties option from the pop-up menu. Note that there are a number of options that can be set, from the type of the list to display and the sorting order used, to displaying options such as the quick filter buttons. So now let's have a look at two of the most common forms of the list and see how exactly it can help you to manage your SCADA systems. First, let's focus on the events list, which provides a summary of all the events within a SCADA system. This includes all active alarms and other system events such as operator controls, logins and logouts, and startup events. As such, it's a great way to audit your SCADA system. There is a special feature unique to the events list that helps with system audits. This is the ability to add comments to the events list, which comes in two forms. The first is an operator message, which allows an operator to insert a message into the events list. This is useful if an operator wants to broadcast a message. So for example, if an operator wanted to warn of an impending reboot of the system, he could create a comment like, "System shutting down in 5 minutes." And you'll see here that the comment is displayed on the list, adding information such as the name of the operator that made the comment and its date and time. The second form is an event comment, which allows an operator to add a note to a specific event in the list. These allow an operator to make relevant comments to events as they happen, rather than having to remember months down the line during a system audit. So for example, if an operator has knowledge of the cause of this alarm, he can comment on it by right-clicking the event, then creating the comment such as, you can then see that the comment has the same date and time as the event, making it easier to determine which event was being referenced. This makes auditing a system not only easier, but more relevant and reliable in the information it gathers, saving on man-hours when trying to determine the cause of a specific system event. So that's an overview of the events list. Now let's focus on the alarm summary list. So this is the iPower alarm summary, which provides a list of all the active alarms within a SCADA system. It's a great tool for managing alarms and provides a number of features, such as the ability to quickly declutter the list by using the quick filters. Here, the quick filter and sorting options available within the list controls is very useful, as with just a few clicks, you can very quickly condense it to display only the most important alarms. You can zoom into a specific area and then filter based on an alarm priority, and then can just as easily clear the filter. This feature is vital to alarm management as it minimizes distracting or nuisance alarms to operators, allowing them to easily focus only on the most critical alarms. You can also right-click on the alarm summary to access the iPower pre-built menu. Here you can acknowledge or shelve individual alarms. More importantly, you can also perform these operations as a batch. So for example, I can select a group of alarms here and I can acknowledge them. Or I can select all of these alarms here and shelve them all. These operations also work in conjunction with the sorting and filtering options for the list controls. For example, I can filter to just the high priority alarms, and then perform a batch operation on a selection of the alarms from the filtered list. So here you have an example of how the alarm summary list from iPower can very quickly help you to manage a cluttered alarm system with just a few clicks, allowing you to focus on more important operations than just acknowledging alarms. So that's an overview of the list controls from iPower. Now let's have a look at the secure control dialogues. iPower provides a universal control dialog that is secure and consistent across the entire platform. This means that no matter where it is invoked, whether from a device dynamo, or a list, or a script, the control interface is always the same, which makes it easier for operators to learn. The controls are also secure, and only one operator can access it at any given time to prevent conflicting controls. The dialog also times out at a configurable time to prevent any one operator from indefinitely locking out a device. As you can see, there are a number of tabs available within the control dialog. By default, the control tab is always the first tab displayed, and this is the main interface for sending controls in iPower. Sending controls in iPower is a three-stage process, which helps to minimize accidental controls from being sent. The first stage is selecting the control, the second is clicking the operate button, and finally, you confirm the control to send, though the final stage is a configurable option. iPower also provides a number of methods for managing when controls should be sent out. The first is the control tag, which is a manual lock applied by the operator to a device, preventing controls to it. So for example, if we knew that the circuit breaker was being serviced, we can put a control tag like this to show that operators should not send any controls to it. The next time anyone on the network tries to operate the device, they'll see the control tag applied, and note that they no longer have access to the control dialog until the control tag is removed. There is also a less restrictive version of the control tag called the information tag, which serves more as a warning to operators rather than as a lock. For example, if I noticed that this device was giving me faulty readings, I can apply an information tag to it like this. And now, anytime an operator tries to control this device, the first thing they'll see is the information tag. But unlike the control tag, they will still have access to the controls dialog after they've seen the warning. Note that both control tags and information tags have their own lists, and this is a great way to manage what tags have been applied. You can have a system-wide list of tags, or you can have a list that's specific to a location. Regardless of how it's applied, you can actually remove any applied tags from the list itself by double-clicking on its entry. So for example, from this list, I can remove the information tag we've just applied, and when I now click on the device, it's back to normal operation. Also, as a side note, all of the operations that we have been doing are all being logged in real time in the events list, including operator names and timestamps, which again helps greatly with auditing a system. Aside from the control and information tags, CIMPLICITY provides a third option, which is the control interlock, which is an automatic lock applied to a device based on conditions within the SCADA network, as opposed to the manual nature of control and information tags. Let's move to the CIMPLICITY system to demonstrate this feature. So here in the CIMPLICITY demo system, we have a similar substation diagram to the one we've been using in iFIX. We have the familiar control dialogues as well as the lists, and if I try to control this device, I can send an open control without any issues. However, if I try to send a close control, you'll notice it gives me a message saying that it cannot perform the control because of an existing interlock. If we want to see the details behind that interlock, we can click on this button here, and it gives us a diagram showing that in order to close CB5, either incomer 1 or 2 need to be live. In terms of the substation diagram, it just means that either these 2 breakers need to be closed, or these 3 breakers should all be closed. So let's try to meet the conditions of the interlock. If I close the circuit breaker here, this should now allow us to send the close control to CB5. So if I retry the close control, you can see that the interlock is now gone, because we have met the conditions necessary to send the close control to CB5. So here you can see just some of the tools provided by iPower to not only make control systems more secure, but it allows you to add intelligence to the management of the SCADA network, allowing operators to be more efficient in their day-to-day tasks. In addition to secure controls, iPower also provides a number of tools within the control dialog. These include such features as manual overwrites, which is useful in situations where the reported value of a point is not the same as its actual value in the field. A manual overwrite will allow the operator to forcibly correct the value to match the actual value in the field, providing a more sensible and consistent display. iPower also provides the ability to manage alarms from within the control dialogs. From the Alarm tab, you can acknowledge an alarm or even pre-shelve it. Normally, you can only shelve an alarm once it has occurred, but in iPower, you can proactively shelve an alarm. For example, if I know that this device is soon going to undergo maintenance for the next 2 hours, I can shelve it now before it generates a large number of nuisance alarms. This way, once the maintenance work commences, the alarm summary is not cluttered with an alarm flood. Finally, there are a number of reference tabs that can be used to provide additional information to the operator. You can review switching information and I/O addresses for related database points, which are handy during commissioning work. And there are also options for displaying basic trends, auxiliary screens, and even create a note for the device. Notes are a handy way for operators to make comments about the device, which are kept in a handy text file, complete with its own version history. Operators can use this to keep track of maintenance schedules, or even just as a general record of faults observed with a device. So as you can see, the control dialogs not only provide robust and secure controls, but a host of other features that operators commonly use. Best of all, these features are all available out of the box and does not require any additional coding, allowing you to concentrate on more important tasks from the get-go. Next, let's have a look at the display management features available in iPower. iPower also provides options for managing multiple displays. You can arrange the pictures on a display according to various arrangements from tiled, horizontal, vertical, and cascading. This feature makes it easy to view multiple pictures across a single monitor, especially on a large screen. If your SCADA client workstation has a grid of monitors, for example a 2x2 grid, there's also a feature for multi-monitor displays that allows you to send a picture from one monitor to another in the grid, using the Send To controls available from the right-click pop-up menu. Finally, iPower provides an auxiliary screen that allows for the display of multiple information tabs, appropriately called the tab display. Every tab contains a single display, meaning that anything you can put in a picture can be placed in one of these tabs. Here in this example, the first tab contains a faceplate of the device, while the other tabs contain an alarm summary, an events list, and even a trend picture. You can also put in third-party ActiveX objects, or even bitmaps, or display a document using a PDF viewer. For example, in this tab, we are displaying the manual for the device as a handy reference for the SCADA operator. So those are some of iPower's display management features. Now let's have a look at some of the deployment features available within iPower. In addition to its runtime features, iPower also provides a utility to aid with the configuration and deployment of projects. This utility is called DB Architect, which is available from the main menu. DB Architect is a database management tool that aids with the rapid deployment of a project by allowing you to create templates from existing objects within the database. For example, if we wanted to replicate the circuit breaker, you would first create a new template for it, then create the new blocks from that template. First, let's create the template from the circuit breaker. You simply right-click on the device required, then select the Create New Template option from the pop-up menu. You then give the template a name and other useful information such as a description and the name of the author. Once you've defined these, click on Apply and the new template will be created under the Templates tree. Once you've created the new template, you can now create new database blocks simply by right-clicking on that template, then selecting the Create New Blocks option from the pop-up menu. You can now specify where the new device will be located, and for this demo, let's place the new data blocks in a different location. You can also specify changes to the I/O addressing of the new data blocks. You can either choose to place them in a different RTU, a different OPC server and group, or just simply offset them from the existing I/O addresses. After that, you can now click on the List Blocks button, and DBA will provide you with a list of the data blocks that are about to be generated. From here, you can still choose which data blocks will actually be generated, and once you're happy with the list, you can click on the Generate button to start creating the new data blocks. Once it's finished, we can now have a look at the system tree for the brown substation, and from there we can now see the newly created data blocks. Aside from templates, DB Architect allows you to manage the SCADA database in a more organized manner than just a flat spreadsheet. As you can see here, the database is presented as a hierarchic tree, and you can double-click entries on the branches to bring up the familiar database editor dialog. Note also that you can create a template from any level of the tree. For example, you can create a template for the entire substation by just following the procedures I've just demonstrated. So with DB Architect, creating new data blocks is not only quicker, but it's also less error-prone than using an I/O schedule, as the process is largely automatic and allows you to leverage your existing devices to serve as templates for new ones.
So in this demo, we demonstrated some of the features that are available within iPower. I hope I was able to show you not only how easy it is to use iPower, but more importantly, how it can help you through all the stages of your SCADA system lifecycle. Note that there are other features available. If you're interested, check out our new videos on iPower. And if you'd like a deeper dive, please contact your local rep and they will arrange one for you.